Hello everyone, welcome to my channel Next Gen Start. Today we are going to see very interesting concept that is GAN, Generative Adversarial Networks, and understand how they generate realistic new data using two networks. Okay, so just take a look at these faces. They look like real people, right? But if I say these people don't actually exist, then you will get surprised. Obviously, these images were created by artificial intelligence. And one of the technologies that can create incredibly realistic images is called a GAN. GAN stands for Generative Adversarial Network. And in next 5 minutes, I will explain exactly how it works without any complicated mathematics. So let's start with a simple story. For a moment, just forget about computer and technical things, okay? So just imagine two people are there. The first person is trying to make fake money, and the second one is detective whose job is to identify fake money. Now just imagine their game. What is the game actually? The fake money maker creates a fake note and gives it to detective, and the detective looks at it and says this is fake. So the fake money maker learns from the failure and tries to make better fake. Again the detective checks it and again detective tries to catch it. But this time the fake is a little better. So the detective also has to become better at spotting fake money, right? And this process keeps repeating and repeating. The fake money maker keeps improving and the detective keeps improving. The better the detective becomes, the better the fake money maker has to become. And eventually, the fake money becomes so convincing that the detective can no longer easily tell whether it's real or fake. That is the basic idea behind GAN. Two systems compete with each other, and because they compete, they keep getting better. Now let's connect the story to the actual GAN. The fake money maker is called generator, and generator job is to create something that looks real. But where does it start? It starts with something called random noise, or we can call that as a random vector z. You can think of random noise as a collection of random numbers. The generator takes this random input and transform it into an image. At first, very first time, the image may look completely meaningless. Okay? But during training, the generator gradually learns how to create more realistic images. Now we have the second part, that is detective. In a GAN, detective is called the discriminator, and its job is very simple. Just look at an image and decide is it real or fake. The discriminator receives two types of images. First, real images from the training data set, and second image, or we can say fake images created by the generator. So the discriminator tries to correctly identify which images are real and which ones are fake. At the same time, the generator tries to create images that can fool the discriminator. Okay, so we have a competition here between generator and discriminator. The generator says, I am going to create a better fake, and the discriminator says, I am going to become better at detecting it. So this happens again and again during that training period. The discriminator performance provides a learning signal that helps the generator improve, and generator's increasingly realistic output gives discriminator harder examples to classify. This back and forth competition is why the word adversarial appears in GAN, that is Generative Adversarial Network. Now you might be thinking, what is new in this? There are multiple AI models that can also produce images like this. So what makes GAN special? So the interesting part is the competition between two generator and discriminator. In many machine learning systems, a model is trained towards a particular target or objective. But in GAN, there are two models running against each other. The generator is trying to fool the discriminator, and discriminator is trying not to be fooled. So, the challenge keeps changing as both models improve. If the discriminator becomes better at detecting fake images, the generator has to become better at creating them. And if the generator becomes better at creating realistic images, the discriminator has to become better at detecting them. This competition can produce very realistic outputs, but there is also a downside of this. Because two networks are learning together, GANs can be difficult to train. Sometimes the generator doesn't improve properly. Sometimes it may produce very similar outputs again and again. So, about all these problems, we will talk in our next video. We will see very simple example to learn actual concept with proper process. Okay, so we will consider this simple example for it. Suppose we want to train a GAN to generate handwritten numbers. Okay. At the beginning, the generator doesn't know what a handwritten number should look like. So, its first output might look like random noise. Not very impressive, right? But the training continues and the generator creates images. The discriminator checks them because discriminator is having some training data set and the images generated from generator. So it will compare, it will check with that images and it will produce some feedback. Generator will learn from the training signal which it will get from discriminator in the form of feedback, and the process will get repeated again. After some time, the output may start looking like rough shapes. Okay, then those shapes begin to resemble numbers. And after more training, the generator may produce clear images that look much more like real handwritten digits. The important thing is that we didn't simply give the generator a rule saying this is exactly how you draw a 7 or you draw 8. Instead, the generator learns patterns from the training process. It gradually learns how to produce outputs that look similar to the examples it is trained against. Okay, so that's the power of GAN idea, to learn with process. So let's quickly recap everything. A GAN has two main parts, that is generator and discriminator. Generator creates new data, for example, images starting from random noise, and discriminator looks at data and tries to determine whether it is real or generated, or we can say fake. During training process, these two networks compete with each other, and the generator tries to create output that looks real, and the discriminator tries to distinguish real outputs from generator ones. And this competition helps the generator improve. So if you remember only 3 things from this video, remember these. Generator creates, okay? Discriminator judges, and competition helps them improve. That's the basic idea behind a generative adversarial network. In the next video, we will go one step deeper into this. We will open up the generator and discriminator and understand what is actually happening inside these networks, including the basic mathematical idea behind their training. Okay, so if this video helped you understand GAN, don't forget to like and subscribe. I will see you in the next video. Thank you.